today we're going to see this basic principles of suspensions that we use on vehicles. And you're seeing here a mass spring damper system that we could use as an example. As you can see in here, the suspension system, basic suspension, is going over the terrain in here, and so it receives an input over here. And these are the basic components. You have a mass that is the vehicle, or in here, or part of the vehicle, and you have a spring and you have a damper. All these three things plus the input from the ground, which you could see is in the form of a velocity input here. Um, they perform a certain function to the system. So we have this as a basic system. So we're gonna, let me disappear from here and we'll continue with this. So what are the what is that we need to do? In this case, to understand this, we we need to do a to understand the mathematics behind this. And to do this, we need to apply Newton's equations. Okay, like for example, in here, we will do over here. Like doing a free body diagram of this. This is the forces that act on this. Obviously, the weight in here. Yeah. And then you see this is going to, if we move and define the motion of this, let's say in the y direction this way, yeah. So we move this a little bit, you're going to see that you have this force opposes, and so does the other one. This in here is going to be k times y in here, and this would be v times y dot, like that. So if we apply Newton's equations for this, what does it say? Newton's law says that the summation of forces equals to the rate of change of momentum, m times dv dt. I mean, in other words, we know this also, mass times acceleration. So this is the summation of the external forces equals to the rate of change of momentum. It's a different way of saying. So what do we do here? We have to say the the value of the forces that we have minus mg, which is down, minus k times y, minus v times y dot. This has to be m times y double dot, like that. Okay? So this is the system differential equation in this case. The suspension, let's call it the system differential equation. In other words, what is the value of y at every instant of time? Now, to do this, we have several tools. One of those is the MATLAB and Simulink tool, which you have taken some classes on this. And if we have this equation, we could actually build a simulation model that will reveal, where it is. So in this very basic suspension system, we could actually make a little model in Simulink that will produce the response. So I would like to give it a try to that. In this case, one way of doing is to translate the original equation into a little picture. If this is my double dot like this, as the result of the function, of the summation, it follows that we could actually build this block diagram by, this would be minus mg, like this, and you will have minus k times y, and you will have this b times y dot, like that. So this is the basic translation of this summation of the terms into this little picture. If you continue in here and, for example, you cause a operator to 1 over m, what is left is again y double dot. If you integrate this once, you will obtain y dot. If you integrate twice, you will obtain y. Yeah, there you go. You see, once you have this integration here, it follows that you could actually build this and multiply this by b, and then you'll connect it over here, or you go down here like this, and you connect it with this k, and this would be this is, remember, this is minus over here, huh? So minus minus, and this too. Yeah. If you put this a plus, you can put the minus over there. But this is the basic Simulink model that can be used to solve the differential equation. This is a scoping here where we can actually see. If you want the output of the velocity, what will happen is you can create another scoping here that allows you to see. Okay, and so the question is now if we could actually use Simulink with this, and the answer is obviously yes. What you need to do is run MATLAB first. So you see all programs, and you go to MATLAB, and then Simulink is a toolbox of MATLAB. So if you have this if you run MATLAB here, here's what will happen. You have this as a immediately calls a Simulink, and using Simulink you could actually produce a simulation of this model, and that's what we're going to try to do. So Simulink is an environment that allows us to graphically enter these block diagrams, and Simulink actually solves those. So let's see where it is. I don't want to make sure that, yeah, there we go. And so we need to look for a new one. Okay, so what we need to do is to translate that model that I had on paper, this one, into this. And to do that, I'm gonna need some tools. I'm gonna need some, well, I'm gonna need some, where is it? We need this guy. See? So we need this, and of course, like that, maybe. There we go. Okay. There you go. See there, that's all I need. I need a small one. So what we do is we go to the commonly used blocks and we'll bring all these things. So we need a constant. We need about 2 or 3 of these. Let's just put those over here. We need the integrators. Okay, we need the integrations. And of course, we need this, and we need a summation point. And we have 2 integrators. Those are these guys. One here and another one. This we are going to reverse by doing a control line like this. Okay, now we are ready. The first thing is this is mg, so I double click in there and I'm just gonna put the value is m and then times g like this. Yeah, there we go. And then in here we have this is how many do we need? So this is we have all 3 negative ones, right? There was 3 of those, and all 3 were minus. There we go. Then you have this one. This one was the one on the left here. So this is fairly quickly. Go over, put the control key and click on the other one. It will actually produce the junction. Okay. This was 1 over m, right? Yeah. This will become connected to this one. Okay, and this is the other one. If we're following this diagram. The only thing we don't have is the extra scope for the velocity, which we should get. I thought we had a scope on this menu. Don't know. The scope is not here. Okay, so now we have the structure and we have the, you can click on the scopes because those are the eyes to the thing. This is going to be the value of B, and then you have, this is the value of K. Okay. So in the MATLAB window, we could specify those values. Yeah, right here. You have that. We're gonna put some numbers just so we can get some plots. M is equal to 2. Then we have like M, like G is equal to 9.81. And then we have I think the damper on the case, so the value of B will be the value of and then I think we only have the R element to worry. No, we did. Okay. Let's see what else does it say. I'm just gonna run the program. This says gain 2. Gain 2. Where's gain 2? This one error evaluating. We don't have the value of k. That's the problem. So let's try again. Run. Yeah. Okay. So now what we need to do is to run it. Do we have both scopes or just one? We need to have both. There you go. This is so I don't think that it will complain anymore. It actually did. Here we go. This is the results of the simulation. Okay, so this is our output in here. I think we have a bit of a difficulty with the values. So we need to check this out. This is what we need. You need to check B, K, and M. Do we have the value of B? No, that's what we do not have value of B. And then no, B minus 3, B is equal to 3. And then let's run it again. So we could change the value of the parameters to make it look like, no, this does not, definitely these curves do not look normal here. So we need to check to see if we didn't do a mistake. So these are the three things that are minus, and then 1 over m. Yeah, that's over here. See, you have all the 3 minus equals to this, and we have m. Oh, I know why. G is not defined too. I think it would have given me some problem. G is equal to 9.81. Let's see what happens with that. Okay. I think we have the MATLAB. We have run the wrong MATLAB file. There we go. Okay, let's what happened is that let's just start over. It says m is equal to 1, b is equal to 2, k is equal to 1 over 20 as we had. And then g is equal to 9.81. Okay, and now we will run it again. It's just that our values were sort of off. And so then we have this. Definitely we like in this case, this is what we could change and debug the value of the suspension on the parameter, but that's exactly how we do it with Simulink. But you can